Hi and welcome to the Mindflux channel. If you are looking for some fun facts about black holes, then this video is for you. Let's jump in. What is a black hole? Well, a black hole is a region of spacetime where gravity is so strong that not even light can escape from it. The theory of general relativity predicts that any sufficiently compact mass will eventually deform spacetime to form a black hole. A black hole is an area of space where the pull of gravity from a massive object like a star or galaxy prevents light from escaping. When matter falls into a black hole, it never comes out again. When a lot of mass gets compressed into a small enough space, the result becomes what's called a singularity. A black hole's gravity is so powerful that it will be able to pull in nearby material and consume or eat them. The black hole is a mysterious, exotic object in space. While it's classified as an extremely dense object, the gravity that compresses matter into this small of a space causes some very interesting effects, ripping apart the fabric of time and space to become what we call singularities, destroying anything nearby with its powerful force. There are many things about these objects still unknown and yet to be explained by science despite having been studied for decades. However, due to their fascinating traits and importance when it comes to studying stars and galaxies, we will probably continue to do so for a long time. Black hole in a nutshell. A black hole is a frightening creature that sometimes pops up when an irrational amount of matter collects in one place. At their center, gravity becomes so strong it rips apart anything and everything in its horizon. We've examined properties of black holes that reveal gravitational fields that move at speeds close to the speed of light itself. Insane, right? Could a black hole eat the universe? In short, no. It seems like black holes are too picky to eat galaxies whole, but the gravitational reach of these supermassive monsters is large enough for them to consume a galaxy's worth of dust and debris. They are physically small, and exert the same gravity as an equivalent mass at distance. This means that if I place all of the Milky Way's matter into our central, theoretical black hole, at least theoretically possible, it would not have any more or less gravitational influence on other galaxies than without a central supermassive object in its center. For example, Andromeda will eventually join us, therefore be consumed by this milky hole we call home. The universe is expanding, so even the combined gravity of all galaxies in our local group won't be able to keep those distant stars from receding past the cosmic horizon where light can no longer reach us. Our galaxy is shaped like a spiral, with an extended thin disk and large bulge. Our little Earth has 400 billion stars inside it. The cool thing about the universe are black holes. There's only 0.1% of all the stars that ever form will become one, mostly between 4 to 40 solar masses in size, but some grow much larger, to many thousands of solar masses, topped by our supermassive galactic center, containing millions more than us humans could fathom, 4 million suns worth for just one hole. Black holes are like mussels. They feed only on things that fall close to them, and so the gravitational field of a black hole is weaker near it than far away from it. For instance, take our own galaxy's center as an example. The distance between Earth and this supermassive black hole would be about 11 light days or 16,000 minutes if we replaced the Sun with one there instead, not even halfway across our solar system. How do astronomers calculate the mass of a supermassive black hole? Well, astronomers take careful measurements from stars and galaxies to figure out how fast they're moving. They can then use these motions as an indirect way of calculating their speed, which means that they know how much gravity is pulling them towards something massive and dark, most likely a dense object, like a huge ball with no light, some type of black or dark star. These calculations are used in conjunction with other factors such as dust clouds around young stars, certain ions coming off old red giants, emissions radiated by pulsars on neutron stars. What would happen to you if you fell into the black hole? There is no way to know what exactly happens inside a black hole because of their inescapable nature, but here are some predictions made by the scientists. Number 1. If you fell into a black hole, you would be instantly crushed by the intense gravity. Number 2. You would orbit the event horizon until your orbit decayed and you were pulled in. Number 3. The closer to the center of the black hole, the faster time moves for you. Number 4. Eventually, time would stop altogether as light can't escape from inside a black hole. Number 5. The black hole's gravity would keep you from ever coming back out, even if you were traveling at light speed. What is Hawking radiation? Hawking radiation is a type of black body radiation that was theorized to be released by black holes, and it's named after the physicist Stephen Hawking, who first proposed its existence in 1974. Do black holes change size? Well, black hole evaporation is the process by which black holes lose their mass and rotational energy to Hawking radiation. It has been theorized that this will eventually cause these objects to shrink until they vanish. The rotational energy of the hole reduces, and it gets smaller as time goes on until they disappear altogether. As the black hole eats more and more matter, it grows in size. But not only does Hawking radiation cause a shrinking effect, but also an increase in temperature, as energy escapes from the event horizon of this object. That's it for today. Hope you enjoyed the video. Please subscribe to our channel, and hit the bell icon for more videos like that. Thank you from the Mindflux.